Well, hello there, my friends. It's good to see you. This is Mr. Von Ah, and we're going through the algebra section of the GED / high set section. This will help you in all sorts of different avenues and all sorts of different exams that you might have to take. All right, so we've been talking about solving systems of equations. We've solved it graphically, we've solved it with substitution, we solved a real life situation. And this is our last video in this segment of systems of equations, part 4 of 4. And we're going to learn how to solve systems of equations using elimination. Okay, so this will be the third different method that I'll teach you in solving these. And they all have their place. Right? It's not that one's better than the other, they all have their place. But if I were to choose one method to always use, it would probably be the elimination method. And so we're going to take a look at 3 different examples because there's 3 different types of situations you're going to find yourself in, all right? So here's our first example, but before we do that, here's some steps. This is a typical process you would go through to solve systems by elimination. All right, first you're going to make sure you line up the like terms. What does that mean? Well, if you take a look at this example here, you see how the x's and the y's and the constants are all lined up? That's what you want. Okay, so make sure they're lined up. Secondly, if necessary, you're going to need to multiply one or both equations by the least common multiple so that one set of terms are opposites. And you'll see this come into play in the second and third example. But in this example, you'll see that the y term, they're already opposites. I got a negative 3y and a positive 3y. So I don't even need to worry about this step 2 for this first example. Step 3, I'm just going to simply add up the equations, which is going to end up eliminating one of the terms, which is why we call it elimination. And then we're going to use substitution to solve for the second variable. All right, so let's get right into it. So I got an equation here. Actually, I got a set of 2 equations. And I want to solve. I want to find what x is and I want to find what y is. If I have 2 variables, I need 2 equations. All right, since the terms are lined up, like I said, and since we have opposites here already, I can move right into step 3, which is add up the equations. So I like to just add them all up. All right, so 2 plus a negative 4x, or I could just say 2x minus 4x, is negative 2x. All right? Adding up the y's, you'll see negative 3y plus 3y. You see what happens? They get eliminated. They cancel, and that's why we call it elimination method. Okay, so I'm done with my y's. They're gone. Now the 0 plus a negative 1 is just negative 1. All right? Okay. So now, boy, that was nice, wasn't it? Just totally got rid of my y term. Now I can solve for x. And I know how to do that. I just divide both sides by negative 2, right? Multiplication principle. Those are going to reduce to 1. So I get 1x, or just x, equals negative 1 divided by negative 2. And negative divided by negative is a positive. So it's just going to give me positive 1/2. All right? So now I'm going to use substitution to solve for the second variable, okay? So now I know what x is. Now I need to find y. So I can substitute 1/2 into either one of these equations. It doesn't matter. Just choose which one you think is easier. To me, it looks like the first one is easier because I got a 2 instead of a negative 4, and I have a 0 instead of a negative 1, right? So I'm going to use this top equation, all right? So I'm going to go ahead and use that top equation. So 2x, so 2 times x, and I know that x is 1/2. So I'm going to multiply that by 1/2. So 2 times x minus 3y equals 0. Okay, so I have only one unknown. So half of 2 is 1. So I get 1 minus 3y equals 0. Right? I just evaluated this right here, multiplied this. Okay, so I want to get y by itself. That means I need to use my addition principle. I need to get rid of this 1. I need to add its opposite. So I'm going to get rid of that 1 by subtracting 1. Right? Because why? Because our goal is to get y all by itself. So by getting rid of that 1, it gets me one step closer. So 1 minus 1 is 0. So now I'm left with negative 3y equals negative 1. All right? Now, this is multiplication. The inverse of multiply is divide. So I just divide by the same exact number. All right? That's going to reduce to 1, which can give me 1y, or just y, equals positive 1/3. Okay, so now I have both of my coordinates, so I can write it as an ordered pair. So my ordered pair would look something like this. My x first, 1/2, comma, my y second. That's the, remember, the solution to a system of ordered is an ordered pair that is true for both equations. All right, so there's my solution. Now that one, believe it or not, was fairly easy because I already had everything, my opposites, all ready to go. Let me show you another example where it's a little bit tougher. All right? All right, let's do this. I have my second equation. I have 3a plus 3b equals 15. Get rid of that there. And then I have 6b plus 2a equals 22. All right, so I have a system of two equations I want to solve for a and b. All right, so first thing I need to do is I need to make sure that all my like terms are lined up. Are they lined up? They're not. See how a is not lined up with a? Okay, so I'm just going to move one of them around so that they are lined up. And I'm going to cheat since I have a whiteboard. I'm going to switch these two. I'm going to put 2a over here and 6b over there. 2a and 6b. There. Now they're lined up. Now I go to number 2. If necessary, I might need to multiply by an LCM. So I take a look. Do I have anything that is equal and opposite? I don't. Right? Remember last time I had a 3 and a negative 3? I don't have that here. So I need to multiply one or both equations by the LCM so that one of the sets of terms are opposites. And so I look here, I have A's and I have B's. I look here and I say, okay, well, if I was going to make these opposites, the A's, I would have to multiply, what's the least common multiple between 2 and 3? Least common multiple, well, 3 is what? 3, 6, 9. Multiples of 2 is 2, 4, 6. Right? So 6 is the least common multiple. That would mean that I would have to multiply this one by 3 to get 6, and this one by 2 to get 6. I'd have to multiply both equations. There's an easier way on this one. All right? Look at the 3 and the 6 on the B term. All I would need to do to make, I need this to be a negative 6, right? If this was a negative 6, if that was a -6 like that, I'd be perfect, right? It would all be lined up opposites. How would I, but it's not a 6, it's a +3. What would I need to do to, what number would I multiply 3 in order to get a -6? Well, I just multiply by -2. Right? So I'm going to multiply this whole thing by this LCM, least common multiple. Right? Actually, that's not really an LCM because I'm only dealing with one equation. But you get my idea. All right, so as long as I multiply the whole entire equation by -2, I'm fine. All right, so let's go ahead and distribute that -2. So -2 distributed to all 3 parts. All right, so -2 times 3a is -6a. -2 times 3b is -6b. And -2 times 15 is -30. Kind of running out of space here, aren't we? Don't forget to multiply this last one. A lot of times people just carry that over as a 15. Okay, I got to multiply everything by -2. Okay, now this one I'm not going to multiply anything. I'm just going to carry it straight over. So it'd be 2a plus 6b equals 22. And if you'll see this right here? See how they're equal and opposites? And they're going to eliminate, which is what I want. Okay, so let's go ahead and add these up. You know what I'm going to do? I'm going to move this over here because I'm kind of crowded over there. So let's move this down here. -6a minus 6b equals -30. And then 2a plus 6b equals 22. All right? Okay, now I'm going to do step 3, which is add these guys up. Let's add them up. -6a plus 2a is going to result in -4a. And look at this right here. Isn't that beautiful? That's going to just cancel. It's going to eliminate. So then I get equals -30 plus 22 is -8. Oh, look at that. See how nicely that just falls out? Okay, this is multiplication, so I divide both sides by -4. That's going to reduce to 1, leaving me with a equals +2. +2. All right, pause the video and see if you can figure out what to do next. All right, I'm going to use my substitution to find the second variable. I know that a is 2, so I'm going to use either one of these equations, or I can use these, it doesn't really matter. Which one of these do you think is going to be easier, the top one or the bottom one? You know, they're pretty much the same. I'm just going to go with the top one, just because the numbers are a little bit smaller. All right, so let's go ahead with this top one here. So I got 3a. Oh, but I know what a is. I know that a is 2. All right, so I can substitute 2 in for a. Plus 3b equals 15. All right, I get that right there. All right, now I only have one unknown. So I can go ahead and multiply 3 times 2, which is 6, plus 3b. Just bring everything down. Okay, I need to get b by itself. So I need to get rid of that 6. I get rid of that 6 simply by subtracting it to both sides. That's going to cancel. Bring down the 3b. 15 minus 6, is that 9? Now I use my multiplication principle. This is multiplication. So I divide. That reduces out to 1. So I get b equals 9 divided by 3 is 3. All right, so my ordered pair then would be 2, again, put them in order. A comes before B. So 2, 3 would be my solution. All right? So everything on that one was the same, except, I had to line up my like terms on that one, and I had to multiply by this multiple over here. All right? Now, we're going to do one more. And this one's going to be a little bit tougher. A little bit tougher. But you can do it. All right? All right, let's take a look at what this last one's going to look like. Okay, so I got 2m plus 3n equals 17. And then I have 5m plus 7n equals 29. All right, if you want to challenge, see if you can do this on your own. All right, we'll take a look here. First of all, are my like terms lined up? M's, N's, beautiful, that's done. Okay, do I need to multiply by an LCM? I am going to have to do that, right? Because these are not equal and opposites. And I can't just simply, like if I multiply this by 2, that's going to give me 4, right? And or by 3, it's going to give me 6, right? If I multiply this by 2, it's going to give me 6. I'm going to have to multiply both of these equations, all right? So what I need to do is I need to choose, am I going to change the m's or am I going to change the n's? Well, let's take a look. Let's look at 2 and 5. Let's consider 2 and 5. 2 and 5. The multiples of 2 are 2, 4, 6, 8, 10. Multiples of 5, 5, 10. Whoop. My LCM was 10 between 2 and 5. How about 3 and 7? What's the least common multiple there? Well, 3, 6, 9, 12, 15, 18, 21. 7 is 7, 14, 21 is my least common multiple. Right? So I don't know about you, but I like smaller numbers. So I think 10 is going to be the easier way to go. Now you could do this, right? You could work with the ends. Totally fine. I'm going to go with the easier one though. Okay, so I'm going to go ahead. I need this to be a 10 and this to be a negative 10. Or vice versa, right? As long as they're opposites. All right, so that means, what would I need to multiply this number to make that 10? Just need to multiply it by 5, correct? All right, 5 times 2 is 10. What would I need to do to multiply this number to make it a negative 10? Well, just negative 2, right? Negative 2 times 5 is negative 10. That will get this m term to be equal and opposite. All right, so let's go ahead and distribute. In fact, why don't you do this? Why don't you pause the video and see if you can get the rest of this from here on your own. All right, how did you do? Did you get a solution? Let's see if you were right. So let's go ahead and distribute that 5. 5 times 2m is, let's do this in a different color here. 5 times 2m is 10m. 5 times 3n is 15n. And it's going to be equal to 5 times 17. Oh, it's 5 times 17. 35, 85. right? Now, what's negative 2 times 5? That's negative 10n. Negative 2 times 7 is negative 14n. And negative 2 times 29, what is that? It's 58. All right, now I just add them up. Add them up. That's going to eliminate. 15 minus 14n is just 1n. And see, what's 85 minus 58? Is that 27? So n equals 27. Look at that. Done. Solve for n. Okay. Now how about m? Still need m. Let's use substitution. Alright, substitution to solve for m. Alright, so I can use either one of these. I'm going to go ahead and use the top one without the 5, right? So I'm going to go 2m plus 3n. What's n? 27 equals 17. All right, 3 times 27 is 6, 7, 8, 81. So I got 81 equals 17. Bring everything down. All right, I need to move this over. So I'm going to subtract the 81 to both sides. That cancels, leaving me with 2m equals, what's 17 minus 81? Let's see here, 7, 8, 9, 10, 11, 4. 64, and that's going to be a negative 64, right? Because the negative is bigger. All right, so let me clean that up a little bit. All right, now I just divide by 2. That's going to cancel, or reduce to 1. And so m is going to be half of 64 is 32, and that's a negative. All right, so my ordered pair then would be, ordered pair, m comes first in the alphabet, right? So I got to go negative 32, and then n is 27. That, my friends, is the solution. So I had to multiply both equations by a least common multiple. All right, once you get kind of the hang of that, these become pretty easy, all right? So I hope this was helpful to you. Make sure you subscribe to my channel. You'll get notified of all my videos. And click on the link below, and there'll be a link there for notes that you can use for these lessons. All right? Until next time, my friends, may God richly bless you.